Welcome everyone. This is the fifth edition of VergeCloud's webinar series. Today's topic is Video CDN 101 and what actually impacts streaming quality. So today, joining us today is Yedukrishnan. He's a solution engineer at VergeCloud. If you follow us on social media, you may already seen this in his introduction post. So Yedu is a recent addition to the team and an expert on CDN architecture and application security. So Yedu, without further delay, I'll hand it over to you.
Yeah, I think we can get started now. Yeah. So hi everyone, welcome and thanks for joining in. I'm Yedukrishnan. I'm a solution engineer at VergeCloud based out of Bangalore. So today we are doing a session called Video CDN, and the reason why we chose this topic is honestly, when I talk with a lot of engineering and product teams, and most of them have video streaming running in production, but very few of them have actually sat down and gone through what's actually happening at the CDN layer. Like, why does buffering happen? What are the actual number of numbers you should be tracking? What does cache hit ratio actually mean for viewers? That kind of stuff. So that's where we are going to cover. That's what we are going to cover today. So it's a 40 minutes of session, and then 30 minutes of content will be there, and we'll do a 10 minutes of Q&A at the end. Feel free to drop any questions in the chat as we go. I'll pick them at the end. All right. Let's move on to the next slide. Yeah. So let me start with some numbers, because I think these put together into some perspective. So 53% of viewers, so more than half of them, half of the viewers will leave a video if it buffers for more than 3 seconds. Not even 30 seconds, 3 seconds. So half of the audience is gone before they have even seen anything. Then every second of as you can see in this the next part, in every second of buffering delay, every 1 second of buffering delay, that costs about 7% in ad revenue. So if you are running ads on your stream, buffering is literally costing you money in real time. And across the whole industry, streaming platforms lose over $10 billion a year because of poor quality. That's a lot of money, right? Now, here's the thing, and this is a kind of whole point of today. Most of the streaming quality problems doesn't start at your server. They don't start with your content. They start at the CDN layer, the delivery layer, which means most of them are fixable. Okay, let me show you what I mean with a real example. Next. Yeah. So IPL, right? I think most of the people who have joined this call have at some point tried to watch an IPL match on a streaming app like Hotstar, Geo Hotstar or something, and hit the spinning circle at the exactly wrong moment. So let's think about what's actually happening here. During a big match, you can have around 50 million people hitting the play button almost at the same time. 50 million simultaneously. That means 50 million simultaneous requests, right? So that's a huge amount of requests. So what happens without a proper CDN setup? All 50 million of these requests are going to your going to a single server or origin server, one server. Or it can be even a cluster of server trying to handle 50 million of people at the same time. Obviously, it will collapse, right? And your viewers are sitting there watching a buffering screen, or worse, even a black screen. Someone misses the winning 6. Now, with a proper video CDN, what happens is that the stream is already cached at multiple edge locations across the globe or across India. a viewer in Bengaluru is being served from a node that's maybe like 20 kilometers away. A viewer in Delhi is being served from Delhi. Result, 50 million concurrent users or viewers at the same time watching the IPL. Zero buffering. And the cricket fans get to see the six. This is basically what a CDN does. It brings the content close to the viewer, doesn't have to travel far to get the content. I mean, for the request to travel far. Yeah, next slide. Yeah. So why does buffering actually happen? So there are basically 4 reasons. Let me go through each one. First is a POP distance. So POP stands for a point of presence. Basically, the edge server closest to your viewer. If that server is around 1000 kilometers away or something, every request your video player makes is doing a long round trip. And every extra 100 milliseconds of round trip time increases the chance of a rebuffer. So so the fix is simple in theory. More POP locations closer to your viewers and the less round trip time. Second, network congestion, especially during peak hours. During prime time, live events, matches, routers will get overloaded, packets will get dropped, and your player will start buffering, and it causes retransmissions. So a CDN with good routing, Anycast routing specifically, can work around this automatically. So third point is cache miss. So this is a big thing that we need to consider. So when a video segment is not cached at the edge node or at the POP, the player has to go all the way back to the main server or the origin to fetch it. That can add around 200 to 800 milliseconds per miss every time. So you want to cache want a high cache rate limit. I mean cache hit ratio, ideally above 90%, which means that 90% of your requests are being served from the POP. So no origin trip is required for this. And fourth, the bandwidth drop. So your video player is always measuring the available bandwidth that and switching between quality levels. So you might have seen this, but there is a lag. If bandwidth drops suddenly, the player doesn't react instantly. The buffer empties and you get a freeze. So good CDNs help here with prefetching and better ABR tuning. ABR is something which I'll cover in the next slide. That is called adaptive bit ratio, bit rate. Then so for 4 things a CDN addresses. That's a framework. Next slide. So before we go further, I want to quickly cover latency. What is latency versus throughput? So because people always mix these things up and diagnose the wrong one and waste a lot of time. So latency how long it takes for the first bite to arrive. Think of it like ordering food from Swiggy or Zomato. Latency is the time that it takes from the restaurant getting your order to the delivery person. It controls things like how quickly your player shows the first frame, startup time, and for live streams and all. How much lag there is between what's happening and what the viewer sees, these kind of things. So throughput is different from latency. Throughput is how much data you can move per second. So once you collect the food, once the delivery person collects the food, so we will bring the same analogy here. So throughput is how wide the road is, how many vehicles or how many pizzas at the same time can move through a road at the same time. So throughput controls the maximum bitrate you can deliver, whether it is HD or 4K is even possible for a given viewer. So if your stream low to start, let's say that's a latency problem. So you look at the POP coverage, edge proximity. If your stream keeps dropping at a low quality, even after it starts, that's a different problem. It's a throughput problem. Different diagnosis, different fix this time. A good CDN target is under 100 millisecond round trip time to the edge pop for latency, and at least 3 to 5 times the stream bitrate available at the edge for throughput. Next slide. Okay, so I have mentioned about adaptive bitrate streaming. So you might have seen this thing. The video quality. Suppose if you are playing some video, the video quality will automatically adjust based on your connection. So on the left side you can see a graph, right? So that's called a bitrate ladder. Your video is encoded into multiple versions like at 240p, 480p, and 240. So for example, take here 240p at 300 kilobits per second, all the way up to 4K at 25 megabits. These are all separate files, all stored at on the CDN or available at any time on demand. So what your player is doing, every 2 to 5 seconds, it's measuring your bandwidth, how good is your internet connection. Based on that, it picks the highest quality version that can be delivered without buffering, and downloads a small video in small chunks, like in segments, usually 2 to 6 seconds long. When it's need to switch the quality, it switches most of the time. You barely notice a quality changes. So now here's a CDN specific thing. All of these quality levels need to be cached at the edge, all of them, right? Not just a popular one, because if a user's connection dropped and the player needs to switch from 1080p to 720p, but 720p, suppose if it is not cached at the edge, that switch causes a cache miss, right? Then the request has to travel a bit far, like it has to travel more, and that will cause buffering again. Simple idea, but a lot of platforms miss it, this adaptive bitrate thing. The next slide. Yeah, so coming to the next slide. So geography is a big factor here. So this is probably the most underappreciated factor in streaming quality. So just look at this chart. If a viewer is in the same city as the pop under 50 kilometers, suppose if there is a pop which is 50 kilometers nearby the viewer, then the route trip time is about just 5 milliseconds. That's excellent. You won't feel any buffering or anything. The streaming will be butter smooth. So same region under 300 kilometers, 25 millisecond is still even good. Some country, but far, maybe like 1,500 kilometers, you are at 65 millisecond. That's acceptable. Maybe not that good compared to the previous ones. Then there will be cross-continent one, maybe more than 5,000 kilometers, and at that point, rebuffering is basically guaranteed. Obviously the rebuffering will occur, and it can cause issues to the quality of user experience. Now for India specifically, India is a really huge. It's a huge country, right? You cannot just have just a single pop deployed at Mumbai and cannot sit back and call it done, right? You need multiple pops at Mumbai, Delhi, Chennai, Bengaluru, at least minimum in tier 1 cities, just to cover major metros decently, right? But the thing is that a lot of platforms are missing tier 2 cities. So as soon as as we know, the IPL and other cricket matches, the sports events have a user bases all over India, right? Even in rural areas. So it is very much required that we should have a POPs at the tier 2 cities like Jaipur, Lucknow, Bhubaneswar, and all. So these cities have really fast growing internet user bases. If the nearest POP to someone is in Lucknow is in Delhi, that's maybe like 500 kilometers away. It's acceptable, but it's not that excellent. And for live sports and all, people feel that lag. So geography basically matters a lot, and it's often the cheapest fix for a streaming quality problem. Next. Then packet loss. So this is one kind of invisible until it is not. I'll give a quick definition. When data packets are traveling from the streamer to the viewer's device, sometimes the packet gets dropped, right? Network congestion can have cause this bad routing, overload, hop overloads. It can be anything. When that happens, the video player has to wait for some time for the packet to be retransmitted, and that buffer will cause or can cause quality of experience draining. So the number here is pretty alarming. Just 1% of packet loss causes 4 times more rebuffering. Just 1%. That's not a lot of loss at all, and it's not unusual on busy networks, especially mobile and all. What actually happens is that when packets are lost, 4 things. Your playback freezes. The player is sitting, they're waiting for the missing segment. Your quality drops. The player thinks bandwidth fell, so it switches down, right? So your startup time is slower for new sessions, and ultimately the viewers leave. So how does a good CDN reduce packet loss? 3 ways mainly. One is shorter paths. If the content is served from a nearby POP site, there are fewer network hops between the streamer and between the streamer and the viewer. Fewer hops means a fewer chance of the packet getting dropped. Then the second one is the anycast routing. So the CDN automatically sends your traffic to the closest pin node. If one route has congestion, it reroutes. It takes another route. The viewer doesn't see anything here. It will work as it is. So the third one is TCP optimization at the edge. So when retransmission happens, they're handled locally at the edge nodes, basically. They don't cascade all the way back to the streamer. Suppose that keep retransmission, really low. Next. All right. Now we have mostly covered all the courses. Let's talk about how actually we can measure this streaming quality, because I see a lot of terms monitoring uptime and thinking they are good. Uptime is not the same as quality. So five metrics are there actually that matters. Also, first one which I have mentioned here is time to first frame. So I think in website, basically we have seen first content full paint. So this is something similar to in case of the video analogy. Time to first frame is something that's how long from the viewer pressing the play button to the video actually showing. That's the time between the clicking on the play button and the video actually showing. Under 2 seconds, that is good. That is a good metrics. Above 4 seconds, you are losing people. So viewer abandoning, quitting watching the video, and it spikes for every spikes like 20% for every extra second. So this is the first impression that when you look at video platform, right, by a viewer. Then there is a rebuffer rate. So what percentage rebuffer rating is nothing but what percentage of total playback time is spent in buffering. Under 0.5%, it is a good metrics, but above 2%, you will have problem in streaming. Yeah. So the next part is bitrate. Next point is a bitrate consistency. Are you actually delivering at your target bitrate? Above 80% is means that session is hitting target is good. Below thing which we need to be checked. The next thing is a CDN cache hit rate. This is an internal metric, but it is very important basically. So above 90% means 90% of requests are served from the edge without touching the actual server. Below 70%, it means that the origin is under stress. Yeah. Then comes the error rate, the fourth part. Yeah. So error rate is nothing but we have seen in usual request for usually HTTP request, we have seen 4xx and 5xx error, right? 400 to ranging from 400 to 599. So responses, these error rates can cause hard buffering for the videos. So 4xx and 5xx responses on video segment requests, this cause hard failures, not graceful degradations. So it has to be kept below that 4xx and 5xx errors has to be kept below a 0.1%. That is a metric, good metric. Yeah, and the last one, which is concurrent viewers per pop. So a pop should not be like overloaded. Suppose if we are deploying a pop in one region, we should make sure that that pop has enough capacity to bear that much of user base there. Yeah, next. We'll look into the practical side now of video CDN. So if you're currently evaluating a CDN vendor or even auditing your existing, if you have an existing video CDN one, here is actually what you should ask that vendor. Network, like one thing, first thing, network coverage. Where are the POPs that you have? And it doesn't mean the real total number only. It means specifically which ISPs they are paired with. In India, there are Geo, Airtel, BSNL. So you need to check with which ISPs it is paired with. They don't have good pairing. That means there is something to be looked at. Yeah. Then there is protocol support. So we need to check whether the vendor is supporting HTTP 3 and quick protocol. And, protocols like high-speed live streaming, MPEG dash, and both. Then formats like LL, HLS, which is basically low latency live streaming, which will help in low latency live streaming and all. So these are not just nice to have. These are basic requirements for a video CDN, basically. And you have to look at performance commitments as well. You'll have to ask them what is the performance commitments that they offer. Will they give you a cache hit ratio, SLA? Then will they benchmark the time to first frame, which I mentioned in the earlier slide, or the rebuffer rate? This kind of questions we need to ask the vendor or the product. These are just reasonable ask. If a CDN vendor won't commit to these numbers, that tells you something. Then comes the operations part. So there are things like purging the cache and also so how fast we can purge the cache. Do they have real-time alertings? Then stream health, we can monitor the stream health. These kind of things we can monitor with I mean, we should have for the operations part. Next. Yeah. So we are from VergeCloud, so it will not be good if we don't introduce a VergeCloud. If someone of you might have joined for the first time in this webinar. So I'll just quickly give a quick note on VergeCloud, what we do and all. So we are basically an edge infrastructure company headquartered in in Bangalore. We build infrastructure that makes internet service faster and more reliable, close to the user. Our products include cloud DNS with Anycast routing, CDN, then security layer like WAF, DDoS protection, bot mitigation, load balancing, and two things are coming up. Basically, video CDN is currently just recently launched only, so it will be coming soon in the production one. And we have a edge computing coming as well, which is basically function as a service, or basically serverless computing. Everything is built for high concurrency, low latency, geographically distributed workloads and all. This is basically the distribution of a video streaming platform. Okay, in the next slide, I'll just show you what we have been building. So this is what our VergeCloud video platform offers. It's basically a full stack video platform for OTT operators, media publishers, streaming business, and all. And when I say full stack, I mean everything from the moment you upload a video to the moment a viewer watches it in one place. So we have 6 capability areas basically: streaming and delivery. First one is streaming and delivery. So we provide video on demand with ABR, like adaptive bitrate, live streaming, and all those stuffs. Then we provide media operations like library presets, then audios like managing different languages of audio for the same video, this kind of support. Then we provide GPU based transcoding. So video CDN basically requires has to think over the top over the basic CPU based transcoding, right? It requires GPU based transcoding. And we are providing HLS dash format support, SRT support, and all these things. Yeah, and we are bringing up DRM, digital rights management as well, where we can control from the VergeCloud platform itself. We can control what who will be able to, which user should be able to access a particular type of content. And analytics is something which offers which we offer from the VergeCloud part, so where we can have a visibility into how good is the streaming health, how we and we can have analytics like a visibility over different metrics at the individual asset level. And yeah, next. So let me walk you through how this actually works at the VergeCloud side. I mean for the VergeCloud CDN side. So on this diagram, you can see 2 paths, right? There are 2 paths. The top lane is the upload and processing path, and then there is a bottom lane, that is the viewer path. So starting from the left on the top, a customer upload the video. I mean customer in the sense whoever is managing the maybe OTT or a edtech, they'll be uploading a video or whatever uploads to the video panel, and that is our control panel. Basically the video goes into the temporary storage while it's being waiting to be processed. From there is an orchestrator which picks up and schedule the whole encoding job, which the encoding job will be done by the GPU, graphical processing unit. And this is based this GPU which is basically faster than the CPU based encoding, does the actual encoding and converts it into whatever format is required. So all these, so suppose if one customer is uploading a raw video, and the GPU takes care of converting it into different formats like in different qualities and bit rates and everything. And once this is done, the customer gets a playback link which they can embed into their website or application. So now the viewer part, this second layer, that will so the viewer opens a website or a application. The request goes to the POP site or the edge POP, the closest, which will be the closest delivery node to the viewer, the POP site, and the streamer, which is there in Bangalore. For VergeCloud, it is actually located at Bangalore, which is a streamer and other GPU processing and everything. So POP site requests the segments, streamer pushes the stream. So streamer basically pushes the whatever content is there, that pulls from the storage and pushes to the POP site basically. So that's how it works. Next. So why we are building this and why we should care about this? The pain point we hear at most is the fragmented tooling. Uploading is one product. Uploading in, I mean, we are managing different processes at different places, right? Uploading at one place, player configuration in another product, then analytics is a different product. So it all takes a lot of engineering overhead. or technical overhead. Yeah, and the traffic spikes kills the stream quality. So we have spent the last 40 minutes explaining why this happens and all. Yeah. Next slide. So it's almost done. So four things I want you to take away from this one webinar. So one is a pop location is the most controllable variable which we can control for a streaming quality. Having pops at tier 2 cities, it will help us in having a better streaming quality for the customers or the viewers. And second is buffering is not just internet being bad. Buffering is caused by packet loss, cache misses, bad adaptive bit ratio, this kind of things. Yeah. Third part is monitor the right thing. So it can be if you monitor things like time to first frame, pre-buffer rate, cache hit ratio, this kind of thing metrics are to be evaluated at the time of troubleshooting a streaming issue. And fourth, why VergeCloud CDN matters. How our VergeCloud product can help India's huge market of OTT business, tech sector, and more. All right, that was all about the video CDN. So thank you for staying me through this 30 minutes of. I think we took around 35 minutes. I will just quickly check the questions if you have any in the Q&A session. Okay. So first question, what is a good latency target for a live sports? So it can be, it depends. Basically, it should be less than around, when you say latency in sports, it's basically under 50 milliseconds or 50 to 100 milliseconds, basically we can say. That will be the latency target, good latency target. And next question, if the content is cached at the edge, why does buffering still happen? So it, as I said earlier, geography is one thing that that is very underappreciated, right? It doesn't mean that content being cached at edge always clear the streaming issue. So content cached at edge means it can be cached. Suppose there are less number of pops in India region or Indian country, subcontinent. There is a pop in Mumbai. There is no pop in a different region, like in Delhi, there is no pop. Then the round trip time will be more, right? That can cause a content caching not help in streaming end. So having more pops and the content should be within 50 milliseconds of reach, then that will help us in clearing the buffering end. So next question, what is the difference between a cache miss and a bandwidth drop? So cache miss is nothing but suppose if the content is not being cached, a new type of video or a content is not at the Bangalore region, no one has access to particular content, video content. A first user trying to access that, search for it, that request will search for that content in the edge pop. If that content is not there at the edge pop, then it has to check for the other travel to the next the origin server, right? That's why there's a that's a cache missing. Bandwidth drop is nothing but due to different metrics like router overload and TCP connection issues. The bandwidth can drop. Like it's basically the internet issue basically. So cache miss and the bandwidth drop is basically two different things. It differs a lot. Next question. What is realistic time to first frame target for an OTT platform? For the OTT platform is basically, I'll have to check on that. What is the exact, but I can say like a calculated amount of around 100 milliseconds. That would be the, or 50 to 75 milliseconds will be an approximate realistic time to first frame for a target, like for an OTT platform, basically. So DRM, yeah, that's it. I think we have covered 3 questions, right? 1, 2, 3, 4. 4 questions. Any more questions you can ask, and we'll cover that as
I think that's the last of the questions, and that brings us today to for being Yedu for such a wonderful presentation today. Hope you all enjoyed it. If you have any future topics in mind, do let us know in the chat, or you could reach out to us on social media. And yes, again, thank you for joining and have a great day.